everyone, this is Kalpana here. In this video we are going to solve the given differential equation which is non-exact. So let's get going. Problem: solve xy square minus x square into dx plus 3x square y square plus x square y minus 2x cube plus y square into dy equals to 0. Solution: given differential equation, xy square minus x square into dx plus 3x square y square plus x square y minus 2x cube plus y square into dy equals to 0. Consider the given equation as equation number 1, which is in Mdx+Ndy equals to 0 form. Which is in Mdx+Ndy equals to 0 form. By comparing these two, we'll get m and n. Coefficient of differential dx is your m and coefficient of differential dy is your n. Right, there. M equals to xy square minus x square and n equals to 3x square y square plus x square y minus 2x cube plus y square. If the partial derivative of m with respect to y is equals to partial derivative of n with respect to x, then we can say that the given differential equation is an exact equation. So now let's find the partial derivatives of m and n. Firstly, we'll find the partial derivative of m with respect to y is equals to dou by dou y of 4mx y square minus x square. Since we are doing partial derivative with respect to y, so here x will be treated as constant. This is equals to partial derivative of first term with respect to y, partial derivative of first term with respect to y minus partial derivative of second term with respect to y is equals to, here x is constant, so you can write double as x into partial derivative of y square with respect to y minus partial derivative of a constant with respect to y is 0 is equals to x into partial derivative of y square with respect to y is 2y, which is equals to 2xy. Therefore, partial derivative of m with respect to y equals to 2xy. Now, let's find the partial derivative of n with respect to x. Partial derivative of n with respect to x equals to dou by dou x of, for n, 3x square y square plus x square y minus 2x cube plus y square. Since we are doing partial derivative with respect to x, so y will be treated as constant. This equals to partial derivative of first term with respect to x plus partial derivative of second term with respect to x minus partial derivative of third term with respect to x plus partial derivative of last term with respect to x is equals to 3y square y 2y square are constants, right? So you can write that as 3y square, that is constant, into partial derivative of x square with respect to x plus constant y into partial derivative of x square with respect to x minus constant into partial derivative of x cube with respect to x plus partial derivative of a constant with respect to x is 0 is equals to 3y square into partial derivative of x square with respect to x is 2x plus y into partial derivative of x square with respect to x is 2x minus 2 into partial derivative of x cube with respect to x is 3x square, which is equals to 3 2s are 6 xy square plus 2xy minus 2 3s are 6 x square. Therefore, partial derivative of n with respect to x is 6xy square plus 2xy minus 6x square. Okay, from this we can say that therefore partial derivative of m with respect to y is not equals to partial derivative of n with respect to x, right? From this we can say that one is, that is the given equation is non-exact. Now we need to reduce the given equation to an exact equation, right? So for that we need an integrating factor. Okay, so the given equation is non-exact and also it is non-homogeneous. By adding the powers of each term, we'll get to know that whether the given equation is homogeneous or not. Here having x power 1, y square 1 plus 2, 3, 2, 2 plus 2, 4, 2 plus 1, 3, 3, 2. See, the powers are not same. Since the powers are not same, so from this we can say that the given differential equation is non-homogeneous. Okay? Or you can reduce the given equation. You can just write the given equation in dy by dx equals to some function of xy form. If function of kx, ky equals to function of xy, then we can say that this function is homogeneous. If the differential equation involves a homogeneous function, then we can say that the differential equation is a homogeneous differential equation if f of kx, ky is not equals to f of xy, then we call it as non-homogeneous differential equation. Okay, fine. And also it is not in, that is the given equation is not in y into some function of xy into dx plus x into some function of x into y into dy equals to 0 form, right? Now we'll choose the suitable integrating factor by observing m, n and these partial derivatives. So you're having m equals to xy square minus x square, right? You can take x common from these two terms and you'll get x times y square minus x. So there is a possibility of getting a suitable integrating factor using m and these two partial derivatives using 1 by m times partial derivative of n with respect to x minus partial derivative of m with respect to y. We need to get a function of y alone. So let's see. 1 by, for m, x times y square minus x into partial derivative of n with respect to x is 6xy square plus 2xy minus 6x square minus partial derivative of m with respect to y is 2xy. So here plus 2xy and minus 2xy gets cancelled. This becomes 1 by x times y square minus x into 6xy square minus 6x square. Right. So is equals to, here you can take 6x common from these two terms and you'll get 6x times y square minus xc. 6x into y square is 6xy square minus 6x into x is 6x square by x times y square minus x square. So here x and y square minus x gets cancelled, is equals to 6, which is a real number. Okay. We are expecting some function of y, but instead of function of y, we got a real number. Okay, you can name it as some k. Fine. Then our integrating factor will be e power integral real number into dy. If we get function of y alone, if we name the function of y alone as some g of y, then our integrating factor will be e power integral g of y dy. Okay, but we got real number as a, okay, instead of function of y, is equals to e power integral real number k, for k equals to 6 into dy equals to e power 6 into integral dy equals to e power 6, integral dy is y. So here e power 6y is our integrating factor. Therefore, our integrating factor is e power 6y. Now, we can reduce the given differential equation, that is non-exact equation, to an exact equation by multiplying it with integrating factor. E power 6y times the given equation gives an exact equation. Consider as equation number 2. Can write this as e power 6y times xy square minus x square into dx plus e power 6y times 3x square y square plus x square y minus 2x cube plus y square into dy equals to 0. Or xy square into e power 6y minus x square into e power 6y into dx plus 3x square y square into e power 6y plus x square y into e power 6y minus 2x cube e power 6y plus y square into e power 6y into dy equals to 0, which is in Mdx plus Ndy equals to 0 form. Sorry, M1 dx plus N1 dy equals to 0 form. M1 dx plus N1 dy equals to 0 form. Where M1 equals to xy square e power 6y minus x square e power 6y, and N1 equals to 3x square y square into e power 6y plus x square y e power 6y minus 2x cube e power 6y plus y square e power 6y. If the partial derivative of m1 with respect to y is equals to partial derivative of n1 with respect to x, then we can say that the reduced equation, that is equation obtained by multiplying the given equation with the integrating factor, that is equation 2, is an exact equation. So now let's find the partial derivatives of m1 and n1. Partial derivative of m1 with respect to y is equals to dou by dou y of for m1 xy square e power 6y minus x square into e power 6y. Since we are doing partial derivative with respect to y, so here x will be treated as constant. This is equals to partial derivative of first term with respect to y minus partial derivative of second term with respect to y is equals to, here x is constant, so you can write this as constant into partial derivative of y square into e power 6y minus constant into partial derivative of e power 6y with respect to y, which is equals to x into, this in derivative of uv, right? You know that uv whole dash equals to u dash v plus v dash u. So you can write this as partial derivative of u, that is y square with respect to y into v plus v dash, that is partial derivative of e power 6y with respect to y into u, for u equals to y square minus x square into partial derivative of e power 6y is 6 into e power 6y which is equals to x times partial derivative of y square with respect to y is 2y into e power 6y plus partial derivative of e power 6y is 6 into e power 6y into y square minus 6 x square e power 6y, which is equals to 2xy e power 6y, x into 2y e power 6y is 2xy e power 6y plus 6xy square into e power 6y minus 6 into x square e power 6y. Okay, therefore partial derivative of m1 with respect to y is equals to 2xy e power 6y, or you can take 6 e power 6y common from all these three terms, then you'll get e power 6y times 2xy plus 6xy square minus 6x square. Now let's find the partial derivative of n1 with respect to x. Partial derivative of n1 with respect to x equals to dou by dou x. So for n1, 3x square y square e power 6y plus x square y e power 6y minus 2x cube e power 6y plus y square e power 6y. Since we are doing partial derivative with respect to x, so here y will be treated as constant. This is equals to partial derivative of first term with respect to x plus partial derivative of second term with respect to x minus partial derivative of third term with respect to x plus partial derivative of last term with respect to x is equals to constant here 3y square e power 6y, y e power 6y, 2 e power 6y and y square e power 6y are constants. So you can write w as constant into partial derivative of x square with respect to x plus constant into partial derivative of x square with respect to x minus constant into partial derivative of x cube with respect to x plus partial derivative of a constant with respect to x is 0. This becomes 3y square e power 6y into partial derivative of x square with respect to x is 2x plus y into e power 6y into partial derivative of x square with respect to x is 2x minus 2 into e power 6y into partial derivative of x cube with respect to x is 3x square. Which is equals to 3 2s are 6 xy square into e power 6y plus 2xy into e power 6y minus 2 3s are 6 x square e power 6y. Now take e power 6y common from all these three terms, then you get e power 6y times 6xy square plus 2xy minus 6x square. Okay. See here you are having 2xy first. So we'll write this first. This becomes 2xy plus 6xy square minus 6x square. Right? So as it is. We got as it is. Right? Therefore, partial derivative of m1 with respect to y is equals to partial derivative of m1 with respect to x equals to e power 6y times 2xy plus 6y square minus 6x square. Right. From this we can say that equation 2 is exact. That is, equation obtained by multiplying integrating factor to the given equation is exact. Since the given equation is reduced to an exact equation, now we need to find the general solution to the given equation, right? So, the general solution of equation 2, that is the exact equation, an exact equation is the general solution of the given equation. We know that the general solution of an exact equation which is in m1 dx plus m1 dy equals to 0 form is given by integral over x m1 dx plus integral of terms of n1 free from x into dy equals to c. Right. And also we are having m1 and n1. Now consider the first integral, integral over x m1 dx. Here we will be integrating m1 with respect to x, treating y as constant. Is equals to integral for m1 x y square e power 6y minus x square e power 6y into dx is equals to, here y square 6 e power 6y and e power 6y are constants, and we can write this as, we'll simply split this into two terms, integral xy square e power 6y into dx minus integral x square e power 6y into dx is equals to, now let's say the constants outside the integral, you get y square e power 6y, that is constant, into integral x dx minus constant into integral x square dx, which is equals to y square e power 6y into integral x dx is x square by 2 minus e power 6y into integral x square dx is x cube by 3. Okay, this is equals to x square y square e power 6y by 2 minus x cube e power 6y by 3. Now, consider the second integral. Integral of terms of n1 free from x into dy. So the terms which are free from x is y e power 6y. Okay, the terms of n1 free from x is y square into e power 6y. All these three terms has x, right? All these three terms, since all these three terms involves x and only one term which is free from x, so we'll take it here. Terms of n1 free from x is y square into e power 6y into dy is equals to integral y square e power 6y dy. Now using eyelet, algebraic comes first, so we'll take it as first function. So this will be your first function, and exponential comes next, so this will be your second function. Now use Bernoulli's formula to evaluate this integral. You know that integral u dv equals to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 and so on, right? Now for u equals to y square and dv equals to e power 6y dy. Firstly find u dash. Derivative of y square with respect to y is 2y. U double dash derivative of 2y is 2. And u triple dash is equals to derivative of a constant with respect to y is 0. Right? So the terms from here will be neglected. So we'll have only 3 terms. So you need to find v, v1 and v2. So by integrating this, we'll get v integral dv equals to integral e power 6y dy, then v equals to e power 6y by 6, and v1 equals to integral v, that is 1 by 6 into integral e power 6y dy, which is equals to 1 by 6 into e power 6y by 6. Now find v2. Integral v1 will be our v2. 1 by 6 into 6. 36 into integral e power 6y dy. 6 6 are 36 into integral 6y dy, which is equals to 1 by 36 into e power 6y by 6. Okay. Now we can apply this formula. Equals to uv, u into v, for v equals to e power 6y by 6 minus u dash 2y into into v1, 1 by 6 into e power 6y by 6 plus u double dash 2 into v2, 1 by 36 into e power 6y by 6. Okay, 2 ones are 2 threes are 2 ones are 2 ones are 2, 2 eights are 16. So this equals to y square e power 6y by 6 minus y e power 6y by 3 6 are 18 plus e power 6y by 18 into 6. 6 8s are 48. 6 1s are 6. 6 plus 4, 10. 108. Okay. Therefore, integral of terms of n1 free from x is y square e power 6y by 6 minus y e power 6y by 18 plus e power 6y by 108. Now coming to the general solution of the given equation. Therefore, the general solution of 1 is result obtained from the first integral. X square y square e power 6y by 2 minus x cube. I'll write here. X square y square e power 6y by 2 minus x cube e power 6y by 3 plus result obtained from the second integral is y square e power 6y by 6 minus y e power 6y by 18 plus e power 6y by 108 equals to C. C have e power 6y in all these in all these 5 terms. So we can take e power 6y common from all these LHS part. Then this becomes e power 6y times x square y square by 2 minus x cube by 3 plus y square by 6 minus y by 18 plus 1 by 108 equals to C. Which is the required general solution. So this completes the problem. So we have seen a problem from a non-exact equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.